Scientific thinking in research. By the end of this topic, you should be able to
discuss the different approaches to problem solving,
compare and contrast the inductive and deductive processes in the scientific method, and
assess the components needed for the development of scientific research.
The purpose of science is to expand knowledge and discover the truth. By building theory, researchers undertake research to achieve this purpose. Prediction and understanding are the two purposes of theory, and they usually go hand in hand.
To make a prediction, one must know and understand why variables behave as they do, and theories provide this explanation. A theory is a coherent set of general propositions used as principles to explain the apparent relationships of certain observed phenomena.
The scientific method is a series of stages used to develop and refine theories. Scientific methods and scientific thinking are based on concepts.
Concepts are invented so as to enable us to think and communicate abstractions. Higher-level concepts are used for specialized scientific explanatory purposes that are not directly observable.
Concepts and constructs are used at the theoretical levels, while variables are used at the empirical level. The scientific research process is used to develop and test various propositions using inductive, deductive, reflective thinking.
Scientific research uses an orderly process that combines induction, deduction, observation and hypothesis testing into a set of reflective thinking activities.
People analyze problems differently because they have selective perception and conditioning of the environment affecting them. The kind of questions asked would be different, depending on how they see the world.
Scientific inquiry is one of the ways to analyze problems. Understanding the relationship between science and research will help researchers in formulating the study.
Scientific method.
Science is a definable subject. It tries to describe reality truthfully. It is an institution or a system and a way of producing knowledge. Science is also a product of the system.
To most people, science is classified as hard, physical, biological science, and soft, human science.
The subject matter of science determines the techniques and instruments used in scientific studies. A scientific method is the method researchers use to gain knowledge.
Business research is scientific because it studies business actions and interactions truthfully, such as research in the field of information and communication technology, education, etc.
The basic goal of science is to obtain, with confidence, valid generalizations and to establish relationships between variables. By understanding the relationships, scientists will be able to understand a phenomenon in terms of the patterns of relationships, to make predictions and to determine causal relationships.
Good science uses the scientific method and can be characterized by the following.
It is empirical, meaning that it is compared against reality.
It is replicable or objective, meaning that the researcher's opinion is independent of the results. Other researchers conducting the study would obtain the same results.
It is analytical, meaning that it follows the scientific method in breaking down and describing empirical facts.
It is theory-driven, meaning that it relies on a previous body of knowledge.
It is logical, meaning that conclusions are drawn from the results based on logic. And
it is rigorous, meaning that every effort is made to reduce error. It is noted here that the difference between hard science and soft science is control over confounding variables.
For example, in business, there are factors which may be beyond the control of managers, so there has to be some trade-off between the rigors of science and the pragmatics of business.
There has to be some give and take between the desires of the business people and the desires of the researchers.
Although this will lead to error, as long as the researcher informs the decision maker of the limitations, and the results are qualified based on the limitations, the research should go on to produce the information.
Good scientific research also follows the principle of parsimony, that is, a simple solution is better than a complex solution. Parsimonious research means applying the simplest approach that will address the research questions satisfactorily.
What are the characteristics of good science?
Traditional sources of knowledge.
The following are the common sources of knowledge:
Common sense.
personal experience. Traditional sources of knowledge.
There are many ways of gathering information and acquiring knowledge. Knowledge gained from traditional sources is not scientific, and may potentially have errors.
Information and knowledge can be gained by relying on what everyone knows and what just makes sense. Common sense is valuable in daily living, but it can allow logical fallacies to slip into thinking.
Common sense may contain contradictory ideas that many people may not notice because the ideas are used at different times. Common sense can originate from tradition. It is useful and may be correct, but it may contain errors, misinformation and contradiction.
It may be prejudiced because of beliefs and socio-cultural differences. One can avoid making wrong decisions by accepting the truth that a deficiency of knowledge in common sense exists.
To reduce this deficiency, one has to generate the right kind of knowledge, and common sense knowledge needs to be examined systematically to find the actual cause.
The actual cause can be found by setting up experiments for systematic testing, or continually collecting data to examine the repeat occurrences of an event. Thus, scientific advances are relied on in scientific research, not common sense. The right kind of knowledge is generated through systematic research. Personal experience.
Overgeneralization.
Selective observation.
Premature closure.
Halo effect. The differences between the inductive and deductive models.
In the deductive model, existing theory is used to deduce a hypothesis. The hypothesis is then empirically tested through data collected from the field.
The data is analyzed and the findings are used to validate the hypothesis. If the findings do not fit the hypothesis, then the hypothesis is rejected.
If the findings fit the hypothesis, then the hypothesis is accepted. Consequently, theory is revised according to the findings.
In the inductive model, an observation is made in order to generate an initial concept to provide clearer understanding of a phenomenon. Next, the theory is compared with an existing theory. If the new and existing theories are the same, the existing theory is said to be confirmed or strengthened.
By providing appropriate examples, discuss the deductive and inductive methods.